Hello and welcome to the Space Above Us, Episode 89, Space Shuttle Flight 22, STS-61A, Das Space Lab. Before we get started, I know I said I wouldn't mention the show's Patreon page too much, but I just have to say, wow, it's only been up for 2 weeks and I've already been completely blown away by the response. Once again, to everyone who's donated, everyone who's told a friend about the show, and everyone who's listened, thank you. I won't talk about it again for a while, but if you're interested in joining a space nerd chat room, listening to me make fun of space movies, or just want to support the show, head to patreon.com/thespaceaboveus. Last time, we talked about the first flight of Space Shuttle Atlantis on the mission STS-61J. Well, sort of. The mission was classified, so we sort of talked around it a lot, but that's still something. The 4-day flight saw the deployment of 2 military communications satellites on a single upper stage, and, more importantly to us, welcomed a new orbiter to the fleet. For today's flight, we won't be launching any new space shuttles, and we won't be keeping anything a secret, but it is still a pretty unusual mission. That's because, for the first time, payload operations would not be controlled by NASA. In fact, they wouldn't even be controlled by the United States. As I'm sure you'll recall, the highly configurable, highly capable research platform known as Space Lab was developed by the European Space Agency, or ESA, for use in NASA's space shuttle. The system provided both NASA and ESA with the ability to run sophisticated and targeted microgravity experiments without all the fuss of operating an entire space station. For this flight, things would be taken a step further. Riding in Spacelab's equipment racks would be specialized gear developed by the Deutsche Forschungs- und Versuchsanstalt für Luft- und Raumfahrt, which translates to the German Test Research Institute for Aviation and Spaceflight. To help minimize the amount of German I have to pronounce, I'm going to refer to it by its German initials, DFVLR, or simply the West German Space Agency. Hey, remember West Germany? But that's not all. DFVLR would not only be flying their own set of specialized equipment for Spacelab, but they would be paying for the entire flight, at the low cost of $59 million. I'm not sure exactly when that check cleared, but if we just assume 1985, then that works out to $140 million in current 2019 money. That's actually really cheap. And once again gives some insight into the unsustainable model NASA was operating under at the time. $59 million for a flight only came close to making sense if the shuttle was flying every 2 weeks or so, which was the eventual goal but was still a ways off. For comparison, a quick, unresearched and unsighted internet search I just did tells me that an Atlas V in the 551 configuration cost about $150 million. So, for the price of an EELV, West Germany was getting a week-long mission on the incredibly capable space shuttle, along with a crew of highly trained astronauts to execute their experiments. That's a pretty good deal. Further emphasizing just how good a deal this was, the experiment hardware actually being flown cost West Germany $229 million in 1985 money, which is about $550 million today. So since they were paying for the ride, the West German Space Agency got to call the shots. It also meant that this mission is often known as Spacelab D1, short for Deutschland 1. While control of the orbiter itself would remain firmly with NASA in Houston, payload operations were controlled from Oberpfaffenhofen in West Germany. I want you to know that I looked up the correct pronunciation for that word and just concluded that it was physically impossible. While in orbit, the shuttle would downlink data to ground stations in the US and Europe, with all data being relayed between the Johnson Space Center and the German Space Operations Center in let's just say near Munich. For times when no ground stations were visible, Challenger would continue to use TDRS-1, which it had placed in orbit itself a few years earlier. TDRS data would be downlinked through White Sands, New Mexico, and sent to Houston, and then relayed through a different ComSat to the Germans. And since my notes here have that relay satellite circled with a note reading, "What the heck is this random satellite?" scrawled across it, I guess it will remain a mystery to all of us. Handing over control of payload operations to another country, even a close ally, was no trivial thing on a technical, political, and practical level. So I think this really demonstrates both how comfortable NASA was getting with shuttle mission operations, but also how closely NASA and ESA were working together. This international collaboration on space activities would surely station both organizations for success in the future. Flying on STS-61A was the largest crew ever launched, with 8 people. Just to put this into perspective, NASA launched Alan Shepard, the first American to fly in space, on May 5, 1961. They launched the 8th and 9th American, Jim McDivitt and Ed White, on Gemini 4 on June 7, 1965, more than 4 years later. Today, we'll launch 8 people in about 8 minutes. With such a large crew, and half of them rookies, I can only keep the crew introduction so trim, but I'll see what I can do. Commanding the flight was Hank Hartsfield. We know Hartsfield as the pilot of STS-4, the final orbital test flight, and the commander of STS-41D. This is his final flight, and with his retirement, the end of a notable era of NASA spaceflight. That's because Hank Hartsfield is the last of the manned orbiting laboratory astronauts to fly in space. No one knew this at the time, since several other MOL guys were still active astronauts. Bob Crippen was even assigned to STS-62A, planned to be the first West Coast shuttle launch. But after the Challenger accident, all of the MOL astronauts either retired from NASA or moved up the management chain, leaving Hank Hartsfield as the last to fly, here on his 3rd of 3 missions. Flying alongside Hartsfield as pilot was Steve Nagel. We last saw Nagel only a few months ago, flying as Mission Specialist 2 on STS-51G. Barely 4 months after landing, he's back in the saddle with a whole new astronaut discipline, flying as pilot. This is his 2nd of 4 flights. Mission Specialist 1 was Bonnie Dunbar. Bonnie Dunbar was born on March 3, 1949 in Sunnyside, Washington. She earned bachelor's and master's degrees in ceramic engineering from the University of Washington and later earned a PhD in mechanical and biomedical engineering from the University of Texas. As part of her pre-astronaut work, she applied her ceramics expertise and helped work on the shuttle's thermal protection system. She began working at NASA in 1978 as a flight controller, including working guidance, navigation, and control during Skylab's re-entry. She was selected as an astronaut in 1980, and this is her first of 5 flights. Mission Specialist 2 was James Buckley, who was also Mission Specialist 2 on STS-51C about 9 months earlier. This is his 2nd of 4 flights. Rounding out the mission specialists, MS-3 was Guy Bluford, who we last saw flying as MS-1 on STS-8, which saw the program's first night launch and night landing. This is Bluford's 2nd of 4 flights. Joining the main crew were 3 payload specialists. Considering the nature of this mission, it won't surprise you to learn that all 3 of them were from Europe. Let's mispronounce some names. Payload Specialist 1 was Reinhard Furrer. Reinhard Furrer was born on November 25, 1940 in Vorgl, Germany. He earned a degree and a PhD in physics, working as both a professor and researcher. On this flight, he represented the German Aerospace Research Establishment, and this is his only flight. Payload Specialist 2 and fellow German Aerospace Research Establishment representative was Ernst Messerschmidt. Ernst Messerschmidt was born on May 21, 1945 in Reutlingen, Germany. For whatever reason, I just cannot figure out the European college degree system, but he appears to have gotten some sort of degree and then a PhD in physics. His PhD was related to his work at CERN and had the snappy title of Longitudinal Instabilities of Relativistic Proton Beams in Synchrotrons. This is his only flight. And last but not least, our only 8th crew member, and maybe my favorite astronaut name, Wubbo Ockels. Wubbo Ockels was born on March 28, 1946 in Almelo, the Netherlands. Ockels earned a PhD in physics and mathematics and then put it to use in his work at the Nuclear Physics Accelerator Institute in Groningen in the Netherlands. Ockels seems to have been a sort of weird hybrid of mission specialist and payload specialist. In 1980, he and Claude Nicollier were announced as part of Astronaut Group 9. I even rattled them off back in episode 67. However, if I had done the strenuous research of, counting the number of people, I would have noticed that despite calling their group 19 plus 80, there were 21 people in that group. The 19 NASA astronauts and the 2 ESA mission specialists, who apparently sometimes count as payload specialists. In any case, this was his only flight. At 12 p.m. on October 30th, 1985, after 0 postponements, scrubs, or delays, Challenger lifted off with its record-breaking crew. The only hiccup encountered during ascent was a minor issue with part of the pressurization system for the RCS thrusters, with a valve failing into the closed position. The system runs on 2 redundant, what they call legs, so the crew switched from leg A to leg B, but that started to lose pressure, so they switched back to A, which worked, albeit with a lack of redundancy. I thought this was kind of funny because it sounds like by switching the legs twice, they essentially just turned it off and on again. But I guess if it works for a router, it can work for a space shuttle. 2 hours after arriving on orbit, the crew got to work activating the Space Lab equipment, wrapping up about 5 hours into the mission. Before we dive into what that equipment was exactly, we have a quick special guest to see off. Remember Glomer? The diminutive little 150-pound experimental messaging satellite rode along with us back on STS-61B, but its modified getaway special canister failed to open, trapping poor Glomer inside. Well, it's back, and this time it was deployed at about a meter a second with no issues 12.5 hours into the mission. The little satellite would go on to test the ability to receive and send messages from remote sensors like those left in the ocean. Being able to collect science data with low-power transmitters and cheap satellites would be a lot better than having to go retrieve the sensors by hand. Alright, old business taken care of, let's move on to new business. As usual with a Space Lab mission, the back of the payload bay was jam-packed with a bunch of equipment for performing specialized experiments. In this case, Challenger flew with the space station-like pressurized module, allowing the crew to float down a long tunnel and manually operate the various equipment racks. Most of the experiments were focused on material science, in-space manufacturing, and life sciences. Let's see what we've got. First was the Werkstofflabor, or WL. The WL, like the mission itself, focused on material science and processing in microgravity. It featured a fluid physics module and a whole bunch of stuff related to carefully controlling the temperature of materials. Stuff like a mirror heating facility, a gradient heating facility, an isothermal heating facility, so many facilities. Next is the Prozesskammer, or PK. This device was focused on measuring the flow of both materials and heat. It studied stuff like how heat was distributed in a material and the precise details of phase transitions. After that is the Material Science Experiment Double Rack for Experiment Modules and Apparatus, which was wrestled to the ground and renamed MEDEA, M-E-D-E-A. I guess that's since it was better than the full acronym of MSDRFEMA. This contained a little furnace that would allow the crew to work through a bunch of, you guessed it, material science experiments. Moving out of material science, we've got the vestibular sled, which was somehow abbreviated to VGS. I'm not sure where the G came from, but there it is. This was a pretty cool little thing, where they mounted a seat on some rails and precisely moved the seat back and forth as a crew member sat in it. By carefully controlling the acceleration and velocity of the seat, they could study the crew member's perception of movement. This was yet another experiment trying to suss out the finer details of the vestibular system. The sled was mounted to the floor of Space Lab and ran down the length of it, giving the scientists who developed its experiments plenty of room to play with. Seeing it in action is pretty wild, since it looks less like a science experiment in the back of a space shuttle and more like an amusement park ride. Our second life sciences facility is the Biowissenschaften, or BW. One aspect of this life sciences experiment jumped out at me. It was the first to measure the internal pressure of the human eye while in space. This is notable because these days we know that this pressure often rises with extended stays in space, actually changing the shape of the eyeball and thus the astronaut's vision. They're not completely sure what causes this yet, but it has something to do with the extra fluid traveling to the crew's heads in the absence of gravity. So far, this doesn't seem to be an enormous problem, but is something that'll have to be planned for when we start flying extremely long-duration missions. There are very few glasses stores on Mars. And lastly, NavX, which was an experiment related to precise clock synchronization and using that for determination of your location. I thought this was pretty interesting since that's exactly how GPS works, but the first GPS satellites had been launched a number of years earlier. But it's possible that this was testing technology that would improve the GPS constellation when the next generation of satellites came online. I'm not really sure. All I know is that NavX sat out in the back, aft of Spacelab. Like previous Spacelab flights, the crew split up into two teams in order to work around the clock. The blue team consisted of Nagel, Dunbar, and Furrer, and the red team was Buckley, Bluford, and Messerschmitt. It looks like Hartsfield was just sort of around for whichever team needed him, as other commanders have done, and for some reason, Ockles wasn't assigned to a team at all. So I imagine he just sort of floated around, physically and figuratively. While most of the systems and experiments came online with no problems, the Materials Science Experiment Double Rack, aka Media, had some issues. In order to overcome those issues, the next day the crew opened the rack up and began swapping out parts. Specifically some pressure sensors in the furnace and a lamp. After that, the instrument worked with no trouble at all, but losing 1 day out of a 7-day mission is rough, and a significant amount of data was lost. Since the consumable usage early in the mission looked to be less than expected, initial plans were made for extending the mission by a day to make up for the lost time. But as the mission drew to a close, the numbers didn't look so hot after all, so the extension was cancelled. But that's probably for the best because a number of experiments on board were time sensitive and needed to be recovered soon after landing. I realize we sort of just arrived on orbit for this episode, but to be honest, we've basically covered the entire flight. Once the furnace was repaired, all that was left to do was cycle back and forth between the teams and crank out the science. And that's what they did. Spacelab D1 carried 76 experiments, and 73 worked with no significant issues. The Germans were thrilled with the outcome, calling it, quote, an extremely challenging mission with outstanding results, end quote. Other than a few little tests on the orbiter, stuff like tweaking the water dumps and trying out a gravity gradient attitude control mode, all that was left to do was to pack everything up and head home. Well, that was almost all that was left to do. 6 days, 23 hours, and 40 minutes after lifting off, the crew fired up the OMS engines and began a 3-minute deorbit burn, and Challenger was on its way home. I said almost everything because there was one last test for the crew to do, even after touchdown. Remember back on STS-61D when they got all that damage to the landing gear brakes? Part of the reason for that was the way that the orbiter kept itself straight on the runway. Rather than turning the wheels like a car, and instead just used more brakes on the side that it wanted to turn towards. This sort of tank-like steering got the job done, but could put extra strain on the brakes. To help keep rollout nice and stress-free, Challenger would be testing nose gear steering. Once the shuttle slowed to 115 miles per hour, Commander Hartsfield gently steered off of the center line by about 30 feet and then gently steered back. This isn't quite as dramatic as it sounds since this was in the desert at Edwards and not on the narrow runway at Kennedy. It wasn't the most groundbreaking test NASA had ever done, but Challenger managed to squeeze every drop of data it could out of the mission, even up to wheel stop. After a successful mission and a successful nose gear test and 8,304 feet of rollout, OV-099 Challenger's wheels rolled to a stop for the last time. This was Challenger's final successful mission. And while Challenger's tragic last flight will always garner more attention than its other 9, I think they're worth remembering. So let's take a quick tour of all 9 of Challenger's missions to date. Challenger's maiden voyage was on April 4th, 1983 with STS-6, which saw the start of the TDRS network and the shuttle program's first EVA. STS-7 came next on June 18th, 1983. Launching America's first woman in space, Sally Ride, on her first of 2 missions, deploying some ComSats, and both deploying and retrieving the SPAS-01 free-flying platform. Next was STS-8 on August 30th, 1983, launching Guy Bluford, the first African-American to fly in space. The flight also saw the shuttle's first night launch and night landing, and carried over 250,000 envelopes in its payload bay, one of which now lives on my wall. On February 3rd, 1984, we saw STS-61B, which gave us one of the most iconic spaceflight photos of all time when Bruce McCandless took the MMU for a test flight. STS-41C, launched on April 6, 1984, firmly established one of the unique capabilities of the space shuttle, in-space servicing of satellites. After a rocky start, the mission saw the successful rescue of Goddard Space Flight Center's Solar Maximum mission, the first of many repair and servicing missions. A Goddard spacecraft was in the spotlight again on STS-41G, launched on October 5, 1984, when Challenger deployed the Earth Radiation Budget satellite. STS-51B saw the first of several Spacelab missions flown aboard Challenger when the Advanced Laboratory was launched on April 29, 1985, on the Spacelab 3 mission. The crew wrestled with dozens of experiments and 2 squirrel monkeys, generating valuable scientific data. Spacelab was back with STS-51F on July 29, 1985, which saw the shuttle program's only in-flight abort. Commander Gordon Fullerton turned the abort mode dial to ATO, and Challenger successfully arrived in a stable, if lower than planned, orbit. And on October 30th, 1985, STS-61A, the mission we just discussed, chalked up another success for NASA's second space-worthy orbiter. In all, Challenger had completed just shy of 1,000 orbits, launched 46 different people past the Kármán line, deployed 101,000 pounds spread across 10 satellites, and spent 62 days, 7 hours, 55 minutes, and 7 seconds on missions. Any one of these missions can hold their own in terms of historical significance. They all contributed something important, whether it was extending NASA's capabilities, proving out the orbiter itself, returning priceless scientific data, or simply paying the bills with commercial payloads. We should remember them. Next time, Atlantis is back on the launch pad after a record-breaking 54-day turnaround. And you know, sometimes life is unfair. It was already pretty cool that Jerry Ross and Sherwood Spring got to be astronauts, but they also get to play with giant Tinker toys in the orbiter payload bay? That's just too much. Ad Astra. Catch you on the next pass.